Hi, and welcome back to Intro to Engineering. Today we're going to talk about petroleum engineering. So, if you haven't already done so, go into your learning management system and answer this question. Name one, or maybe two or three products that you use frequently that's made with petroleum. So if you haven't answered the question yet, go ahead and pause the video and take a second to answer it. All right, great. So, some of the products you came up with may be asphalt, or could be gasoline. Those are kind of the common answers, or maybe diesel jet fuel. Okay, but what you may not realize is that petroleum is actually used for a lot of different things, especially plastics. So a lot of different plastic products are made with petroleum derivatives. Okay, so as always, let's take a minute for our safety minute. So safety is important in all disciplines, but particularly in the oil and gas discipline. They tend to have higher fatalities and more safety incidences just because getting oil out of the ground and the process of refining it is a pretty dangerous endeavor. However, you'll notice that traffic accidents, right, vehicle collisions and transportations is actually one of the higher risk operations, which is a risk whether you're in the oil and gas industry or whether you're driving to the grocery store. So you also have explosions and fires and falls. So as with every industry, you definitely want to make sure that you follow all safety protocol. All right, so our objectives for today, we're going to understand traditional and non-traditional oil extraction methods, figure out how we can get oil out of the ground using hydraulic fracturing and all the different aspects that follow hydraulic fracturing. All right, so this is a short video. It's about 2 minutes long. The link is here, and it's going to be posted in the metadata for this YouTube video that I'm creating, and you should watch this on your own. And basically what this video is going to tell you is all about oil and what it's composed of, which is composed of hydrocarbons. So we'll be referring to hydrocarbons, and that's oil or gas that comes from the ground. So make sure you watch this video before moving forward. All right, so oil and gas, where do we find it in the US? If you look at this map of the United States, you see that there's exploration wells and there's petroleum refining facilities. So that really covers the two different parts of getting oil from the ground to the people. So you can see here in Louisiana, we have a lot of both. So we have a lot of exploration wells and we have a lot of petroleum refining facilities. So what's the difference in the two? Well, it's really the difference in what we call upstream and downstream. So upstream is where we search for the oil. That's where we're going out in the field and we're saying, is there oil here? And if so, let's get it out of the ground. Downstream is taking that raw, crude stuff we've pulled from the ground and turning it into final products which can be used. So that's not turning it into a final product like making a tape dispenser, right? But that's creating whatever chemical comes from there, which will then be sent to a plastics facility to make it. So it's taking that raw, crude oil and gas and turning it into something usable. And that's really where we see that the petroleum engineers, which is the discipline we're studying today, is upstream, and chemical engineers are downstream. Okay, so we're not really going to be talking about the refining process. We're only talking about how to get it from the ground. Okay, so your guest speaker or the guest speaker video may have already covered some of this, but I just want to run through these 5 roles of petroleum engineers very quickly to refresh your memory and to just give you an additional resource. So reservoir engineers say, here's where we want to drill. So this is actually a screenshot of a map that was in Vermilion Parish in Erath, Louisiana. And this is a fault line right here, okay? And this red line indicates the top of the oil. Now, I'm not a reservoir engineer, so I don't know what this means or if this means that there's a lot of oil or not a lot of oil. But basically, a reservoir engineer would be able to look at and interpret this drawing. So they're really interested in locating the hydrocarbons. Where are they? Okay, and they use a lot of geology to do so. They're going to use simulations. They determine where the oil is, how much there is, how much we can get out of it, or how much can be recovered. And what type and how many wells. So if you're interested in learning more about reservoir engineers, there's a link there for a YouTube video, talks a little bit more in depth about reservoir engineers. Okay, so a drilling engineer says, here's how we can drill this. So once the reservoir engineer has located it, you got to figure out how to drill the hole. So there's a bunch of different ways and methods for drilling. but basically they want to design and implement procedures to drill the well, and they want to do it safely and economically. So they're going to create designs, they're going to determine their equipment and supplies, they're going to do cost estimation, they're going to do safety analysis. So they're going to make sure that the spot that the reservoir engineers picked, the drilling engineers are going to figure out how to drill a great well. Okay, again, more info on this link. These will all be tagged in the metadata of the YouTube video that I'm creating here. All right, next we look at completion engineer. So basically the reservoir engineer found it, the drilling engineer drilled a hole. Okay, they drilled the well bore. But they have to figure out what, after you drill the hole, you have to actually poke holes and be able to extract the gas. Okay, so this is called a Christmas tree, and they're going to actually decide the best way to finish the wells, so that, you know, once the well is drilled, how do we get the oil that's underneath it to actually flow up and be extracted? So they are the completion engineer. They design this Christmas tree, which controls the pumps and the systems of the well, and they determine where and how to create the perforations along the casing. So we're going to talk a lot more about that. So if that doesn't quite make sense right now, just give it a second and we'll talk about what that really means. Again, there's the link to a YouTube video for more information on a completion engineer, but they're really focused on the best way to finish the well. Okay, production engineers say, great, the well is done, it's perforated, we have oil and gas that is now entering our well and it's ready to be extracted. So now they have to actually extract and produce the hydrocarbons. So they are basically in charge of running the well once it's built. Okay, they're going to monitor and evaluate the production, and you know, the typical building cycle for a well can be several months, but then the production engineers, these wells can sometimes produce for 20 to 40 years, depending on how much oil and gas is underneath there. So the production engineers are in charge of continuing to run the well after it's been dug. Okay, again, there's a YouTube video. And last but not least is a facilities engineer. So facilities engineers can be in charge of designing the all the external housing that needs to happen to get the well to work. So here you see an offshore one, so a facilities engineer would be in charge of designing it. And they also create the pipelines that will combine oil from multiple wells and the pipelines that send it to wherever it needs to go to get processed in the refining process. They usually will help design the systems that separate the hydrocarbons into oil, gas, water, and all other stuff, and how to dispose of things. So they're in charge of really maintaining the facility that helps run the oil well. Okay, so those are the 5 main roles. And in the project that you guys are going to do, you're actually going to get to play the role of 3 of those. All right, so that was kind of a recap. That might have all been a little bit of additional information that you already heard from the guest speaker, but just wanted to go over it again quickly. So what you have when you are getting oil out of the ground is you've got the earth, okay? And this is many, many thousands of feet are represented here. I wish they had a scale for it. And conventional oil methods are really targeting the oil and gas that's located, and there's a big band or reservoir of it. Non-traditional methods are going for the oil and gas that are a little bit deeper. So you have your shale gas deposits down in the bottom here. So let's take a closer look. So conventional methods, like I mentioned, it's a vertical drill. You have a well, and it goes down, taps into the oil, and then that oil starts to come up and you can extract it that way. Non-traditional is called fracturing. Okay, so it's not spelled with a K. A lot of people spell hydraulic fracturing or fracking, F-R-A-C-K. There's no K, it's just fracturing. And this is basically where you can drill a well, and you'll notice there's many wells here, okay? And they're going to different points and they're actually extending horizontally, and they're creating these cracks, and they're actually able to extract oil from a bunch of different places with only one site on top. Okay, so that's a non-traditional extraction method, and those have become more popular as the traditional methods have started to use all the oil that's available. Okay, So in the non-traditional method, you have to break through shale. So shale is a really hard rock, and it actually contains organic material. It was created millions of years ago, okay? And what happens is the oil and gas is trapped inside of this rock in little tiny pockets. So it's not this giant deposit that you can just stick a straw in and start sucking the oil and gas out. This is like spread all throughout in these teeny tiny pockets trapped within the rock. Okay, so the shale rock has to be broken for us to get access to it. And so that's where you can have fracking or fracturing into the shale, and you can do it vertically. So the traditional way can still work, just the go down, but instead of tapping into an oil reservoir, you actually create these fractures in the rock that help you extract the oil and gas. Or you can do horizontal fracturing, which is what we saw a couple of slides ago, where you have a well that goes vertical, but then it's going to go horizontal into that shale rock, and it's going to crack the rock and extract the gas. So vertical is a kind of a more traditional method, and then horizontal drilling opens up a lot more doors, and we're going to see some of the pros and cons of that shortly. Okay, so we've been talking about fracturing, but what exactly is hydraulic fracturing? So hard rock hydraulic fracturing is where you use a water solution. So it's made up of water, sand, and then some other chemicals that help lubricate and keep things going. And they actually get pumped into this pipe, and they break through the shell. So there's very high pressure, and it's going to crack the rock. So you can see here these cracks, okay, that are happening. And those cracks are what allow the gas that's trapped, or the oil that's trapped inside this rock, to flow to the pipe, and then the pipe is going to get pumped up. Okay, so in this case, this is methane. They're extracting methane gas from the ground. Okay, and so the main part here is that you're cracking the ground to get these oil and gases to flow to the pipe and then up and out. And remember, this is thousands and thousands and thousands of feet underground, so you don't feel those cracks. So let's take a little bit closer look at each of the components. Okay, so basically you have to drill the well. Okay, the first part of the drilling the well, you're going to insert surface casing. Okay, so these are steel pipes that go into the ground, and they don't quite look like this. This is just a generic picture of a steel pipe. But that's going to go inside of the well. So your reservoir engineer has found the oil in the shale rock. Your drilling engineer is in the process of drilling the well bore. Okay, so they're going to use surface casing to insert a steel pipe, or they're going to use surface casing, which is a steel pipe, and insert it into the well. Then they're going to put a concrete barrier. So they're actually going to pour concrete through the steel pipe and then out and around, so that the steel pipe is actually cased in concrete, okay, or cement. So they're going to create a concrete barrier. So you have the earth, you have concrete, steel, then you have the cavity that's empty where the oil is going to flow, and then steel pipe again and concrete on the other side. So it's kind of a concrete wrapped steel pipe. Okay. Then, once they've drilled the vertical part and the horizontal part, and they've done the surface casing and the concrete barrier for both, they're going to send a perforating gun through the pipe. And so what that does is it's going to actually poke holes in the steel pipe and in the concrete. So it's going to send blasts, it's going to send explosions that are going to create holes in that pipe. So now we've created a barrier, because we don't want the oil and gas to mix and mingle with the aquifer water and all the like nice soil that's close to the surface. Okay, so that's what the barrier is for. But way, way, way deep down, 10,000 feet below ground, we want to have access to the ground. That's the whole point. We're trying to extract the oil and gas from the rock. So we're going to use the perforating gun to poke holes in the steel pipe and the concrete barrier. Okay. Then we're going to pump hydraulic fracturing fluid. Okay, so again, that's that mixture of sand, water, and chemicals. We're going to pump that down at a really high pressure, and it's going to seep out through those holes that we've created with the perforating gun. And our goal is to get the rock to crack. So we want to create fractures in the rock, okay? Then inside those fractures, you have gas and oil, and that's gonna go back through the perforated holes. We're gonna extract the hydraulic fracturing fluid. The oil and gas is gonna flow back through the cracks, through the holes that you've perforated in your pipe, and then get sucked back up to the surface, okay? You can also use, oh no, this is a isolation plug, so these are just corks, okay? But what they do is they actually crack ground a little bit at a time, and then they put a little plug, and they wait until they've actually perforated the entire horizontal piece, and then they're going to drill out through the isolation plugs to get the gas to flow. So all of this is the responsibility of the drilling engineer and the completion engineer. So the completion engineer deals with how many perforations, where the perforations should go. So really the first two parts here are the drilling engineer, and then here's where the completion engineer happens. Okay, and then after the injection or isolation plugs have been drilled out, then it gets turned over to a production engineer. All right, so this is a really great video. It's about 6 minutes long, and it explains visually what I just described to you guys. So these are some questions for you to think about. And the last question here is there bias in this video? So anytime you watch videos about petroleum engineering, you have to understand who's creating the video. Is it an oil and gas company, or is it an environmentalist? So there's always a battle between the two, and there's no right or wrong side, okay? Petroleum engineers do their job, environmental engineers do their job, and sometimes they conflict. So I want you guys to watch this video and see if you can decide, or see if you notice who created the video. Was it told from the perspective of an oil and gas company, or is it told from the perspective of an environmental company, and why you think that? So this might be a good discussion to have on your learning management system between your classmates, or to have a discussion in class. So these questions are great, and you really need to watch this video. It'll clear up any confusion that I may have caused on previous slides describing the process. Okay, so why do we want to drill horizontally? Okay, well, this is a picture of downtown Baton Rouge. What if there was like a big oil deposit under here? We wouldn't want to replace that really pretty statue with an oil rig. That would just not be pretty. But we could maybe have an oil rig a mile down the road, but drill horizontally and get to the oil that's under this statue. Okay, so you're able to reach places under cities, parks, houses, where you otherwise couldn't reach. Here's another example of it. So in between Dallas and Fort Worth is the University of Texas at Arlington. This also happens to be one of the largest shale fields that we have, called the Eagle Ford Shale. And it's one of the largest shale deposits here in the Southeast. And what they actually did was they hydraulically fracked, and they created one surface well, but they have 18 or 19 wells that come from a single pad, okay? And one of them's even 8 miles away. So they've been able to tap into this huge reservoir with just one pad on top and lots of pipes underneath that reach really, really far away, okay? So they're able to minimize their footprint because they only have one pad, but all of these different horizontal reaches, and you're able to reach places that, you know, might not be available because things already exist on top of them. Okay, so far it sounds pretty good, this hydraulic fracturing. What could possibly go wrong? Well, let's talk about the pros first. So aside from being able to have a smaller footprint above ground and to be able to reach places we couldn't reach before, it is actually lowering our CO2 emissions. So CO2 comes from burning coal, and because of the increase in access to natural gas and oil reserves through shale, we've been able to actually reduce our carbon footprint. Now, there are arguments that the reduction in our carbon footprint is due to other things like a natural or the economic recession and some other reasons. So I'm not saying that hydraulic fracturing is the reason for CO2 emission reduction, but CO2 emission reduction CO2 emission has been reduced since hydraulic fracturing has increased in popularity. The U.S. Energy Information Administration has indicated that they think that the use of shale gas for electricity has contributed to about 30% of the reduction in carbon footprint. So take it for what it's worth. Again, two sides to every coin. Also, it's cheaper than coal, or it was for a while. So because we were tapping into a whole bunch of these new deposits, it actually became cheaper than coal. So people were using that, which also helped contribute to a reduction of the carbon footprint. So some cons, okay? So they do in the hydraulic fracturing fluid, there are a lot of chemicals, okay? They do try to remove it, but if you listen to the video, 15 to 50% of the hydraulic fluid is extracted. So that means 85 to 50% to 85% of the hydraulic fluid stays in the ground. Now this is 10,000 feet below ground, so it's very far away from any aquifer drinking water, but it is, you know, dangerous chemicals that are in our ground. So there's a lot of worry about that, and the hazardous materials, also the land being destroyed where the well pad is created. So if you saw in the video, they say, oh, it goes back completely to the way it was before nature, or it goes back to the way it was in nature before we came. There's some arguments as to whether or not that actually happens all the time. This is also a fairly new way of extracting oil, and so there's really limited legislation about it. And there are a lot of loopholes. So a lot of the laws were written around traditional vertical well bores, and now with hydraulic fluid, it gets a little trickier. Interesting to note that in all of this hydraulic or horizontal drilling, you do actually still have to ask for permission to drill on someone's land. So even if you're 10,000 feet below someone's property, if you're on their property, you still have to ask for permission to get the oil off of their property. So that is good, but there are definitely some exceptions. Like for example, the Safe Drinking Water Act is made for toxic chemical injections into wells during hydraulic fracturing, but there's some rules about it permits temporarily stored wastewater from these facilities to go untreated, and I don't know, there's all sorts of loopholes, and so legislation really hasn't caught up to it. It's kind of like cigarettes when they first came out. There were no hazards or rules about them. Vaping, same thing. I mean, these are new things that are coming out, and we don't always know the implications, and so there are loopholes and there are challenges to face. The third con is the potential for like earthquake damage or collapse. So if you're drilling holes underneath a big city, there's potential you're disrupting the underground structure, and so there's potential for an increase in earthquake damage. So most of what we've talked about is called hard rock fracturing, but in the Gulf of Mexico, when they're drilling offshore, it's really into sandstone. So sandstone would imply it's a little bit softer, right? Because sand and stone, you don't think of the two going together, because sand is loose and gravelly and stone is hard, right? So sandstone is actually very soft rock to cut through. And so this is a short video, it's about 6 minutes long, about drilling in the Gulf of Mexico. So you need to watch this video and compare it to the one you watched about hydraulic fracturing, which was focused on shale. Okay, so sandstone is geologically young compared to shale. That's part of the reason it's not hard. It's just a different type of rock, and it's young. And actually, sometimes it can flow without, the oil can actually flow out from the sandstone without a fracture, or with significantly less fractures. And one of the downsides to sandstone is that a lot of the sand ends up actually coming up with the oil, which makes it a lot harder to maintain your equipment and keep it clean. So there are a lot of challenges that come with extracting oil from sandstone. So make sure you watch this video to compare the difference in offshore Gulf of Mexico versus hard rock fracturing through shale. All right, so now you guys have all the background information that you need to be able to complete the jello fracturing. If you need an example video, there's actually a video online here but you should look at your student handout and have fun with the project.